Introduction to C++. Today I'm going to do the variables lesson. Variables. Each program works with values. A variable lets you store a value by assigning it to a name. The name can be used to refer to the value later in the program. For example, in game development, you would use a variable to store how many points the player has scored. Each variable has a type, which defines the type of the value it holds. A variable can hold a text value, a number, a decimal, etc. We are already familiar with text values. They are created using quotes. Quotes. Text values, quotes. Let's create a variable of type string. This creates string message, semicolon. This creates a variable called message of type string. Now, our variable message can hold string values. In programming terms, the process of creating a value is called declaration. To declare a variable, drag and drop to declare a variable called name of type string. Declare a variable called name. I think it's this variable. No. String name. Check. Yeah. After declaring our variable, we can assign it a value using the assignment operator. String message. Message includes welcome. Now, message holds the value welcome. Note that the string value should be in quotes, so this message is like a box. It's a variable, and inside the variable, inside the box, I have the word welcome. Fill in the blanks to declare a variable called country and assign the value USA to it. Okay. String country. Okay, country equals to USA and then semicolon. Yeah. Now, variables. After declaring and assigning a value, we can output the value of our variable. After declaring and assigning a value, we can output the value of a variable. So there should appear a message that says this welcome, right? Let's run it. So if I run it, string message, inside the message we have welcome. Run, welcome. Drag and drop to declare a variable called name. Assign it the value John, then output it. I think it's string. Oh no, it's drag and drop. Okay, so string name. Name is equal to John. Then quote name. Check. Yeah. Variables. We can combine the declaration and assignment into one statement like this. String message, welcome. String message. So we can write it in the same, just in the same line. This is handy when we already know the value for a variable and makes the code shorter and more readable. I'm not gonna run it. Okay. Variable. A variable can change its value during the program multiple times. For example, the message can change based on the language. String message, welcome. Message, bienvenue. Also, we're changing the original box, the content of the original box message for a different language. Okay. Here we have it. What is the output of this code? String x a, string x equal to b, count x, then x equal to c, then count, then it's gonna be c. No, first it's gonna be b and then it's gonna be c. So BC. Yeah. So a variable has a name and the type of the value it holds. To declare a variable, use the type followed by the name of the variable. The type of the variable. You can assign a value to the declared value using the operator equal. A variable can change its value during the program by being assigned to a new value. Okay, let's practice. Smiley face. The given code declares a variable with a value that is a representation of a smiley face using the add characters task. Complete the code to output the value of the variable and check out the result. So, integer. Now, string smiley. Smiley face. Then I have to put here code. No. Here. Code. Yeah. Code smiley face, right? Smiley, code smiley, and that's it. Your code is not running. The code is missing parentheses for code, and before smiley. Oh, before smiley, it should be code smiley instead. Additionally, there is a missing semicolon after code. Oh, so it's semicolon. We close semicolon here, and then this, I always forget this. No, there is a missing semicolon on line 6 after the string literal, causing a syntax error. The string literal on line 6 is not being executed due to the missing. The semicolon goes after. Yeah, I think it's gonna run. Your code is not running. The code tries to print a string variable, but instead puts the string inside double quotes, making it separate string literal with no effect. The correct syntax is that's what I put before. Or maybe we have to add another semicolon. No. Wait. I'm gonna remove this. Yeah, so it gave me a wrong answer, like a wrong solution to the problem. That's interesting. Data types. C++ supports many different types for your variable based on their value. The int type is used to store whole numbers called integers in programming. Int points. Fill in the blanks to declare a variable called age of type int and store the value 42. Int age equal to 42. To store decimals or float, that's a float point number, C++ provides the float and double data types. For example, double temp. The float type is also used to store decimals. To specify that the value is a float, we need to use the letter F after it. Okay, so float, and what we put before. There is no. Oh, this is a double, and this is a float. In the double, I don't put anything. On the float, I put an F. Float length, code length. Drag and drop to declare a float, assign it a value, then output it. Okay, so there is a float, a variable of a type of float called weight, with the value 19.64 F, count, weight. Float versus double. By default, decimal values are of type double. Float uses less storage in the memory but is not as precise as the double type. This means that calculations that use floats are faster than the ones that use double. However, the results are less accurate in terms of the decimal digit. The best practice is to use double. If you do not have any specific requirements to use float, okay, double, better, double. The char. The char or car? Char. The char type is used to store a single character. It is similar to declaring a string, but uses single quotes for the value. A variable of type char, name x, with the value h. Fill in the blanks to create a valid program that declares a double and a char, then outputs their values. So this is double. This is char. And this is code, capacity and code class. So the output should be this and this. Boolean. I remember this before I saw this Boolean. True or false. Two states. The Boolean type can only hold values, either true or false. It is used when working with conditions. For example, bool online false if the person is online or not, I guess. 0. False is equal to 0. The online variable can show if the user is online or not. When you run the code, you'll notice that the output is 0 instead of false. This is because the Boolean value true corresponds to 1, while the value false corresponds to 0. The Boolean value true corresponds to 1. Integer is used to hold whole numbers, integers. Double stores decimals. Float is similar to double but has less precision and requires less memory. You need to prefix the value with the letter F to create floats. Char holds a single character. And bool can have one of the following, true or false. The given code declares some variables, then outputs them. However, the code is missing the data types of the variable. Task: complete the code by adding the corresponding data types of the variable based on the variables assigned to them. Do not change the values of the variables as they are needed to match the required output. Okay, so here this is a char, no, string. This is this is a float, not a string. Int. This is a float, and I that's it, I think. Oh, input, no input, output, name, count name, and then what is inside name, end line, then count age, put what there is inside age, that is 42, then put this slash height, and then height. Okay. Doing math. C++ supports a number of arithmetic operators that can be used to perform calculations. Let's declare two variables and output their sum. Int A, int B, count A plus B. $32. What is the output of this code? 6, I get x plus y plus z, 9. So it's 3 plus 2 plus 1 plus 3. The result of a calculation can be assigned to another variable. For example, let's use subtraction to demonstrate. There's a price, 20. There is a discount, 5. Total is the price less minus discount. So 15. Multiplication. Multiplication is done using the star operator. Points, levels, result. Points multiplied by levels. And that gives me 84. Fill in the blanks to calculate the area of a rectangle by multiplying the height by the width. The height is 88, the width is 13, so int area, it's int area height, here, height multiplied by width. Count. What is in here? Int area equals, I guess. Yeah. Division. Division is done using the slash operator. Let's calculate how many days there are in 500 hours. Okay, so the output of this code is A, 11 divided by B, which is 4, and that gives me 11 divided by 4, it's 2.75, but I don't have that option here, so what should I put? 2.75, it's closer to 3, so let's put 3 here. No, so then it's 2. Okay, try again. 2. Okay, so it doesn't count. Oh, because it's the integer, so that's why it doesn't count decimals. In case we need a more precise result, which includes decimal points, oh, here it is, we can use doubles. We declare the variable hours of type double, 500, the variable days of type double, which is the hours divided by 24. 20.8333, because we put double. So the percent, the remainder operator, also called the modulo, is used to find the remainder of a division. Let's find how many days will be left over if we divide 500 days into weeks. So we have integer 500 days, and the result is 500 days and the remainder of 7. I mean, the remainder of this division. 3. What is the result of this code? 9, and the remainder, I don't. Okay, so let me quick. 9 divided by 4, that's 2 multiplied by 4 is 8. 8 to 9 is 1, so the remainder is 1. 1. Plus is addition, is subtraction, slash is division, division integers results in an integer. Percent finds the remainder of a division. Percent finds the remainder of a division. Painting a wall. You're painting a rectangular wall and need to calculate the area in order to buy the necessary amount of paint. The variable length, it's 5.6, and height, it's 3.1. defines the size of the wall. Task: calculate and output the area of the wall. So here would be double equal to length multiplied with the star. I never multiplied by height, and then this. Double. I'm gonna put result. Yeah. Your code is not running. Okay. The variable result is declared but not used, causing a warning during compilation. Double. Oh, wait. Code. Oh, code. Double. Let's see. The code attempts to assign the result of a calculation to the data type double and doesn't use a variable for the output. The variables length and height are defined but not used. Result. Okay, I don't know what to do. What if I remove this? No. The result is not declared. Oh. Double result and then this, and then count result. Let's try. Yeah, that's it. More variables. You can declare variables of the same type on one line, separated by commas. Integer x8, integer x2, count. This makes the code shorter and easy to read. When separating multiple variables declarations with the comma, they need to be integers, have the same type. I think it's have the same type. Yeah. Another handy keyword is auto. The auto keyword allows you to set the type of the variable based on its value. The auto keyword allows you to set the type of the variable based on its value. Also, I don't have to mention the type of variable if it does it automatically. Okay, that's nice. So auto x, y, z, count x, then this, and 4 space, then this number, and then space, and then hello. Is this code valid? Auto num 5. No. Naming variables. C++ is case sensitive. For example, the name my variable in minuscule is not the same as my variable in capital letters, and not the same as my variable. These are three different variables. Choose variable names that suggest the usage, for example, first name, last name. All variable names must begin with the letter of the alphabet or an underscore. After the initial letter, variable names can contain additional letters, as well as numbers. Blank spaces or special characters are not allowed in variable names. There are two popular naming conventions. Pascal case, the first letter in the identifier and the first letter of each subsequent concatenated word are capitalized. For example, Pascal. So we don't use space, right? Because we are not allowed. So instead we use the first letter of the word in capital. Nice. Camel case. This is Pascal case. These tiny details are the hard thing to remember, I think. What is a Pascal case? And then camel case. The first letter of an identifier is lowercase, and the first letter of each subsequent concatenated word is capitalized. For example, back color. So Pascal case, every word is capitalized. Camel case, the first letter is not capitalized. Then every word is capitalized, the first letter. Let's see if I can remember this. Right now I do, but then when you are on any code, I think that's the kind of small errors that might appear to forget this. Which of the following are legal variable names in C++? Legal, okay. No. Or yes? Yes, I can use this. This, no. This, yes. No. Yeah. You can declare multiple variables of the same type by separating them with commas. You can use the auto keyword to automatically set the type of the variable based on the value it's assigned to. Remember that C++ is case sensitive. When naming your variables, remember that they need to start with a letter or underscore and cannot contain special symbols. Comments. One more thing before we complete this module. Comments are annotations in the code that explain what the code is doing. Code is for computers, while comments are for humans who read and work with the code. A single line comment starts with 2 forward slashes, like here, 2 formal slashes, and continues until it reaches the end of the line. Storing the height of the user. This is just a demo value. So I guess that when we run the code, these comments won't appear. Fill in the required symbol to make a comment. // You can also comment out lines of code. in case they are work in progress or you don't want to delete them yet. Double hide. What is the output of this code? Integer x. That means 3, because 5 minus 2 is 3. Multiple line comments. If you need to comment on multiple lines or write a multiple line comment, you can use the slash star star slash symbol like this. Star here. This is just a demo program that outputs a name. Star slash. Okay, slash and star, slash and star, slash and star, slash and star. Make this text a multi-line comment. So it's slash and star, some text about the code, and then star and slash. Now you know how to add comments to your code. Here are some key takeaways. Comments are explanatory statements that explain what the code is doing. They can contain notes, to-dos as well as code, to-dos as well as code that is work in progress. Slash slash starts a single line comment. Slash star slash is used for multiple comments. Okay, a local electronic shop has a great deal for notebooks. You want to buy as many notebooks as you can afford. For that, you need to calculate how many notebooks you can buy with the amount in your bank account and how much money will be left over. The given code includes comment as instructions for 2 tasks you need to complete. Follow the instructions to solve this code coach. Okay, so your account balance. This is the balance. Price for each notebook. Here is the price. Task: calculate the number of notebooks you can afford and output it. Hint: use an integer to store the result. Okay, let's see. Int books it's equal to balance divided by price. And then code books. Okay, then calculate the amount left over on your account after the purchase and output it on a new line. Okay, so hint: calculate the total price of the purchase, then subtract it from the balance. Calculate the total price of the purchase. The total price of the purchase is okay, so int amount left over, it's equal to books. No, wait, the total price of purchase. So that is total price of purchase, it's equal to books multiplied by price. Then so the int leftover amount is equal to the balance minus the total price of purchase, and then count a leftover amount. Let's see. There are syntax errors in the code. The variable declaration on lines 18 and 19 are incorrect, and line 20 is missing a semicolon. Oh, maybe.